Hey folks, how's everybody doing today? Happy Tuesday, hope you're doing well. Got just a couple things today. That close down here. We're going to work on loops now, officially in week 6. We're just cruising along, so we're in chapter 5 of our Zybook here. So we'll work on loops, and then don't forget the project is due on Thursday before class starts. Talked a little bit about it in lab, but just make sure you get it in right 3:30 p.m. by Thursday. So that's committing it to GitHub and submitting it to Canvas. Right, you got to do commit to GitHub to make sure you get it to github.com, and then you're going to submit to Canvas so I know to grade it. Right, so otherwise they're not really attached very well. So we'll do that, and that'll be the first project to do. And I did add a rubric for it here. So if you want to go take a look, in case you weren't there in lab, 5 different items at 2 points each, possibly partial credit if there's something there. But so asking for the user for their name and using it in the prompts is 2 points. Setting those initial values for the 4 different account types, 2 points. The savings balance for each account type increases correctly. So like the balance of each of these, not just the savings account, but the mattress doesn't change, the bank savings does change, bonds change, and stocks change. Right, with that formula. And then the future account balances are shown with formatting. So I hadn't asked for formatting before. I said just the value of each type, but let's do the nice formatting here so we don't end up with too many different or too long of a decimal place. I just round to the nearest penny should suffice there. And then our future value adjusted for inflation is calculated and displayed with 2 decimal places as well. So that's the 10 points. So if you submitted it before I attached the rubric, I apologize. You're welcome to go and update it anytime before the due date, and we can go from there. So that'll be project 1. So we're going to talk about loops. Today we'll get maybe about halfway, maybe a little more than halfway or so, and then on Thursday we'll talk about project 1 first thing. So I'll show you how I would go and solve project 1, and then we'll finish up the loops chapter. And then the following Monday we'll do our loops lab, and we'll just keep on that general flow here until we hit midterm week. Let's take a peek here real quick. I know it's October already, so it's time to start thinking about it because we do have our midterm. We're going to do it during the lab time is the goal here for this one. So the strings chapter is relatively short for the things we need to do. So we'll spend some time the Thursday doing midterm review. I'll give you last year's midterm so you can see how I write the questions, that sort of thing. And the questions will be essentially on the same topic. So if there was a question about functions on the sample midterm, there'll be a question about functions on the actual one. It'll just be a different question about functions. So I don't want any surprises. I know exams are awful, but ideally it'll be short and sweet. Shouldn't be too bad. Hey, Trumpet Man, happy Tuesday to you. Good afternoon. Yeah, it's definitely afternoon here. You know, one great thing about CIS courses is they're rarely ever in the morning. And if they are in the morning, it's usually like a later morning anyway. So it's definitely not everybody, but we tend to be a group of people who aren't always morning people. So thankfully we can get on a little bit nicer schedule. All right, and then we're going to keep on cruising through. Don't forget about the quizzes here for each chapter. So we've got the branching quiz, chapter 4 quiz, should be due Thursday. Right? So I'll post the chapter 5 quiz Thursday. You'll have until the next Thursday, 11:59 p.m. to answer it. Relatively short and sweet. They're open book, open notes, no time limit. So that's your incentive to make sure you're actually getting into the book, reading the material, keeping up. And then don't forget to keep up with these iBook activities as well. If you leave it all to the end of the semester, it's a lot of work to get caught up, to actually finish all of those activities and the Xi lab exercises. So like I get a little report of progress here. So it looks like we have 16 people have the book, which is good. I think we're at 17 in the class, so still a little off there. But even like from chapter 1, only 60% of the labs have been completed, right? So those things do add up. And the Xi Labs score, or the Xi book score itself, which is a combination of the labs, the challenges, and the participation, just going through and clicking all the things, make up 10% of your overall score. So those are essentially free points, right? There's a limited tries on those things. You can keep on going until you get it right. So that should be a free 10% for everybody, just for kind of keeping up reading the book. And I would love your feedback too afterwards, what you think of this online interactive textbook. I've generally gotten good feedback because it's cheaper than a traditional textbook, and a little bit more interesting because we can actually like type and write code right in it, which is pretty cool. So I think that's kind of a fun feature here. So. All right, let me fire up PyCharm, and we start looking at loops here. We'll get here. We'll get there. So I think we talked a little bit about this UML notation. And, you know, I think as much as I like that whiteboard app, I'm pretty sure that slows things down even more on my computer. I don't know why. So, but I can draw right in Word too, because I've got my stylus here. So I'm going to try it in Word, and I think this will work a little bit better for us here. Let's give that a shot. Just zoom in a little bit more. Put it in draw mode. Right. So I think we talked a little bit about UML, right? This unified modeling language. Does that ring any bells? Okay, the Word does some weird highlighting, but that should be fine. So that's a way of us drawing pictures. Right? And we talked about with our decision points, right? We'd have this little diamond operator here. We said like, hey, if age is greater than 21, greater than or equal to 21, right? Then you can go have a drink. Right? That's the flow of what can happen. So this is yes here, right? And we'll say if not, right, then you're stuck with pop. Pop only, or something like that, right? And then eventually the program will just keep on going with the next line. So they'll both kind of come back to the next block of code, and the next block of code, and the next block of code, and we'll just keep on repeating. So that's the regular decision point. But what we're going to do with loops here is we're going to essentially go back to somewhere. So when you start off a loop here, we're gonna do something over and over and over until a condition is met here. So let's say if you want to practice something 10 times, we might have, you know, the practice count. Like you should keep doing your math homework until your practice count is, say, more than 10. So if practice count is going to start at 0, and then we're going to loop, right? So we're going to do, okay, so what we need to do is practice. And then we've got a little decision point here, right? So this is the function, the operation that we're going to do, right? And it will increase the practice count by 1, right? So then the other step it's going to do is take that practice count plus equals 1. Writing code in UML is terrible. I'm sorry. I'm just trying to show. So this is as long as that practice count is less than 10, what we want to do is go back to here. If it's not less than 10, right, this is the yes, this is true, this is the no, then we can keep on going with the rest of our code. So it's just going to repeat, 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 repeat until this condition is no longer true. Right, so we want to do something while this is true. So in our Python code, let me start up a new project here. We use the while keyword for that. So this is chapter 5 loops. Do it in this window. All right. So we could do that same silly example, right? So we could have a practice count. Oh, let me zoom that in a little bit here. Enhance. Practice count is 0. And then what we do, we say while, and then we have to give it a condition. Right? We have to give it something, a Boolean result, some Boolean value, or an expression that it will be true or false. So while practice count is less than 10, and then a colon. So just like the if block had a colon, and everything inside that belonged to that if block was tabbed in, a while block will have a colon, and everything that should run in this loop is indented here. Right? So then we have to do our practice. So we'll print practice, and then we'll take our practice count plus equals 1, and we'll just keep on going. And then we can print finished practicing. Now go have fun. I don't know, something silly, right? So as long as this is true, what's going to happen, right? If this is true, we go inside. So it's possible that this isn't true at all, right? We know that because we set it to 0, that 0 is less than 10, it will run. But you know, if we were using some sort of user input, right, it's possible that they give us a number to make this not true. So this will only happen if this is true. And what the while loop does, it says, okay, do everything in the loop. When we reach the end of the loop, come back and evaluate this again. If it's true, do it again. If it's true, do it again. Just like we had the little flow, the little UML chart, right? If it's true, go on back. If it's true, go on back. If it's true, go on back. Repeat, repeat, repeat until it is no longer true. So the while loop runs if the expression or value is true. Right? So you could give it just something that stores a true or false, like a Boolean value. Sorry, my tag's backwards here. You could give it a Boolean value. Sure, that's fine, and we could change that value if we wanted. No problem here. So as long as this is true, it's going to run. When it's done, right, at the end of the loop, goes back and evaluates again. If it's true, it runs. Okay, so we should get you practice 10 times, right, if we run this, and then we finish practicing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we finish practicing. Now we get to go have some fun. We did enough math practice. Right? So we could do that. Now, what if we wanted to have a little bit of fun? Have we looked at generating random numbers yet? I feel like we have. Let me look that up real quick. See if we talked about that. I don't actually remember. Random. Nope. Okay, so we'll get to that in a minute then. That's in the next section. So this is great. So if you want a random number here, what you can do is you can call, so we'll say, here's my first number. You say rand int. Nope, not rand. Rand int. So rand int comes from our random library, which is really cool. So we can import the random library here. So at the top, right, it doesn't know what to do with it right now. It doesn't know what randint is. The suggestion here is, hey, do you want to import random randint? We'll say, yeah, we want to do that. So you can click on that, import, and it adds up at the top this little line. It says from random, import randint. You can say, okay, randint, great. I want a random number. Now what we can do with it is we give it a range inside of here. So how high of a number? So we want from, how about 0 up to, let's go 10. And I think this one's inclusive. I can never remember because Python is weird like that. Yeah, Yeah, it's inclusive. So it'll be a number between 0 and 10, including 0 and 10. It's a random value from 0 to 10, inclusive. Most other languages are exclusive of the upper bound for some reason, but this one is inclusive for sure reasons. Right, the other way you might see this, you might see people say, just I want to import random, and then they could say random.randint here. So if you import random, then you can use random randint. If you say from random import randint, then you can just say, hey, I want the randint line. So either way is okay, depending on what you want to do. Doesn't matter too much. Yeah, this is the one that is suggested for us, so we'll go with this. I think that's nice and easy here. We'll get our first number. So let's do this practice then here. So instead of actually just saying, hey, will you practice, let's print out a practice problem here. And we'll get a second number is randint 0 to 10. Right, and then here's, we'll say problem number. And then let's put in, let's change this. So let's do practice count 1 to less than or equal to 10, because that way I can use the practice count here. And then let's give them an expression. Let's do the first number, or let's do another, maybe a colon, practice number, maybe a dash or something. Now let's move the colon. So practice number, whatever, colon. And then we'll take the first number, and then we'll print out, how about a plus? Let's just do a bunch of addition problems, right? And then second number. Right, so then we can say like, hey, how about practice these, then go have fun. So we're going to print out 10 random math problems here. Again, not very interesting problems, but sure, with some random numbers. So each time we run it, we're going to get different values here, right? So 1, 2, 4 plus 6, 2 plus 4, 8 plus 0, 2 plus 2. We see we get different numbers. That's kind of fun. When we run it again, it won't be 1 plus 2 for the first one. Now it's 0 plus 3, 0 plus 6. Right, so we get some random, sorry, I can zoom it in a little bit here. We get some random values for us to use here to do some practice problems. That's kind of fun, right? And then they'll just print out as many practice problems as they want. So we can actually change that as well too, right? We could have, let's say we want the total problems is an input of how many math problems do you want? And again, we need that as an integer value, right? So we can do some nice comparisons here. And we'll say, okay, as long as our practice count is less than the total problems, let's print it out, practice number, and keep on going. Let's give that a run. So how many problems do we want? Well, let's do 10 again, and we should get 10 problems. If we run it again, and we say we want, I don't know, how about 50? We get 50 math problems. Great, so we get a lot of practice, right? We could fill up a whole sheet if we wanted to. So using the random values every time. Now, do be careful. Random values in Python they're only considered pseudo-random. They're not really random, because you probably are thinking to yourself, computers only do what we tell them to do. So if I know the process of how it generates a random number, it really can't be random, because it's a known process, and that's true. So it's definitely not a cryptographically secure random number generator. There are some really cool math things that you can do to get actually a random number using some cryptography stuff, which is fun, or at least cryptographically secure enough that you don't know how it's generating a random number. So there's whole schools and interesting theories and things that you can do around, if you see a bunch of values, can you predict the next one based on what we know about random number generators in Python and things like that. So there actually was a story, I forget where it was. There was some group of people that were targeting a specific brand of slot machine. And they would go and take a cell phone and put it in their pocket with the camera facing the slot machine. And what they could do is that this particular slot machine was programmed in such a way that as the pictures would cycle through, that was on a random number generator process in whatever language they wrote the slot machine in. And if they watched the sequence of that they could send the images through to some computer. I'm pretty sure it was out in Russia. I could find the article. I think it was in Wired. It would send the series of images out, and it would predict when they needed to hit the button to stop it so that they would get the jackpot. And they were actually able to win money off of these slot machines because they were able to analyze that random sequence to find out, okay, which random seed was this? Because it's only pseudo-random. It's not actually random, to know when to stop. So just be careful with your random numbers. And if you're doing anything involving money, be doubly careful. That was just a bad design for these programmers to use the same random number sequence to do your display as the actual, okay, here's the winning calculation. Right? Because they're calibrated to say, okay, every 1 in 1,000 should win, $500, because that way they're still keeping half their money or whatever the calibration has to be. Right? It's programmed in to be random, and that they win their money. So sometimes it might pay out 3 times in a row, and they'd be down a little bit, but on average, right, they would eventually win their money there. So be careful with random. Random's really cool. What you can do is do some fun stuff with it. All right, I really like this example here. This one's a lot of fun. If you've ever had to calculate the greatest common divisor, this one's super fun. So we'll do print the. Let's find the greatest common divisor of 2 numbers. And there's a little formula for it. So we need the first number. So we'll get a first number is an int of an input, the first number, and we'll have a second number is an int of an input for the second number, right? And then we're going to say while the first number does not equal the second number is our condition here. Sorry, we don't need those parentheses. Bad habit. So while they don't match, right? Because if you gave me the same number, well, obviously we already have the greatest common divisor. Sure. If they don't match, what we're going to do is we need to find out which one is bigger, right? So if the first number is larger than the second number, then we're going to subtract the second number from the first number. We'll take our first number and we're going to subtract the second number. Right? This is the greatest common divisor formula here. If it's not larger, then we do the opposite. We're going to take the second number minus equal the first number. And then we check again. If they match, great, we're done. If they don't match, keep on subtracting, keep on subtracting, keep on subtracting here. And we're done. We can print the greatest common divisor is, and we can print out either one of the numbers, right? Because we know they match. So this will work all the way down to, it's possible it's 1, right? If they're both prime, we're going to get down to 1. But you can keep on doing this series of subtraction, 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 and you'll get down, they both equal 1. So this one's fun. So if we do this again, so how many math problems do you want? If we say 0, right, the loop never ran. We never got any because practice count was 1. 1 is not less than 0. It never runs. So again, there's no guarantee it's going to run first. But let's find some greatest common divisors. How about 39 and what do you think about 12? 39 and 12. Greatest common divisor is 3. Okay, right? 3 times 2 times 2, or 3 times 4 is our factoring for 12. And then what is it? 3 times 13 for the first number. That sound right? And then 13 is prime. So 3 is our greatest common divisor. Sure, let's run it again. We'll give it 2 prime numbers. Any of you folks who are math majors in the class, I'm happy to make sure we're using the right math terms here. So we'll do like about 17 and is it 53? Was 53 prime? Yeah, so our greatest common divisor is 1. Right, and if you want to watch it work, we can put it in debug mode. So come over to the line numbers here, click into the blank space, and we put a breakpoint. Now, instead of right-click run, you want to right-click debug here, and we'll actually be able to see the value of the variables. Okay, sure. PyCharm, yeah, go for it. Oh, I should have clicked private too. Come on. Okay, firewall, thanks. So how many math problems do we want? Let's do 0 again. All right, onto the first number. Let's do, how about 29 and 7. So we're going to get the values here. So the first number is 29, the second number is 7. And now we're going to step. So we want to step over. Okay, so first number is larger. So now 29 minus 7 is going to put first number back to 22. All right. Now they're not equal. 22 does not equal 7. So let's check which one is bigger. 22 is bigger than 7. So 7 subtracted from 22. Now we're at 15 for first number. Let's look at 15 and 7 don't match. So 15 is larger than 7. Let's subtract. Now we have 8 and 7. Okay, they're not the same. So let's subtract. So 8 minus 7 is 1. Okay, first 1 does not equal 7. Now 1 is no longer greater than 7. So now we're going to get the opposite. And we're going to get 7 minus 1. So now second number goes to 6. Second number is going to go to 5, 4, 3, 2, all the way down to 1. Okay, so we just keep on going all the way down. And we'll see we got 1 for our greatest common divisor. Okay, so in debug mode, you can see the values of your variables as it's running, which is super cool. Big fan of that. All right, let's see. Okay. Let's shrink that down. There we go. Let's shrink it down. All right, so other things we can do with our loops. Right? We can use a different kind of condition here. There's this idea of something called a sentinel value. Now, a sentinel value is something that is intentionally off. So that it like is an indication that, okay, I'm going to keep entering a bunch of values here until I'm done. So if I have a stack of receipts and I want to total up my receipts here, we could get that. So we're going to have a loop that's going to run, and it's going to keep on going until we give it that funky value. Okay, so we'll get the receipt total is an int of an input of enter the receipt value to total. Okay, so we'll do that, and we're going to say while the receipt total does not equal, how about we say -1? Because you probably don't have a receipt in your drawer for -1 here. That's our receipt. Oh, you know what? This should be just a regular receipt. This will be receipt here is not 1. And then what we need is we need a place to total all of that, all of those. So we'll say, okay, I've got my total receipts here. We're going to start that off at 0. So if you give me a receipt that's not -1, I'm going to take my total receipts, and I'm going to add to it the receipt value. That's probably not spelled right, but that's okay. Then I'm going to ask you again here. But now I'm also going to say for -1 to stop. So you can just keep on entering values. I don't know how many you have. You might have 1, you might have 50, you might have 100, you might have 1,000. You can keep on going, entering values, entering values, entering values, entering values, until we get the -1 value. Then we're going to stop. Now I also want to track a count of receipts here. And then every time you give me a receipt, I'm going to add 1 to it. So I want to be able to count it here when we're done. So when we're all done with our loop, sorry, we can print here. We can say, you know, you entered count of receipts for a total of total receipts here. And we could also do some other stuff, right? We could say the average receipt is, and then to get the average, that's the total divided by the count. Right, so we can do some interesting stuff here in our loop. So let's give it a try. All right, well, one math problem, 1 and 1. We already got a greatest common divisor. All right, so enter the receipts. So we'll do 10 and 20, 30 and 40 and 50, and then -1 to stop. So we get 150 is our total, right? Average is 30. So it just lets us keep on going here until we give it this sentinel value. That means, hey, stop, right? Just let me keep going here, because I don't know how many you have there, until I give you a value to stop. That's our sentinel value. It's pretty fun. And we can do this with all sorts of things here, right? If you want to keep entering words until you give it some kind of word to stop, go for it. That's fine. This makes it a little bit easier. So the other way you could do this, right, which is maybe a little bit funkier here, if you don't want to use a sentinel value, right, we could do the same process, and we're going to say, I don't know, more to enter equals yes, or a y here. And then we can say while more to enter equals y, let's do a loop here. And we do the same, we'd have a total receipts and a count of receipts, start off at 0. We enter the value here, we get a receipt. Right, and then we will take the total, and we'll take the count. But then, instead of asking for the receipt value at, okay, -1 to enter, we'll ask, do you have any more? So we'll have more to enter equals an input of, do you have more receipts to enter? And like suggest, hey, how about y/n as an answer here? And then we'll reset more to enter. So if they give me a y, more to enter will equal yes, the loop will run again. Oops, I didn't mean to drag that. If they enter anything other than y, the loop will stop. So the sentinel value, let me minimize that here, sorry, lets us skip the second prompt. So if you just imagine running this, what's going to be easier to enter a bunch of values? Right, we'll do 1, 1, 1. Okay, enter the receipt. So 10, 20, 30, 40, 50, -1 to stop. Okay, or I could say 10, yes more, 20, yes more, 30, yes more, 40, yes more, 50, no more. Right, so it allows us to eliminate that extra prompt. There's nothing wrong with it, but just in terms of being easier to use, if we can take advantage of one of those sentinel values, like if there's a known value that is out of range, that you're not going to have a receipt for -1, good. This will work nicely for us here. All right, let's see. So that's our input until we get the sentinel values. We can run a certain number of times, right? Just do all sorts of arithmetic here. And actually, this gets to be more interesting. So if you look at the first project here, we could do a loop instead of the math here if you wanted, for fun. So let's just ask them here. So we'll have a stock or current stock value, stock investment value is an int of an input, or maybe even a float. I don't know. Probably a whole number here. Input, what's the current value of your stock investments? And then let's just, we'll do a fixed number here. So we'll have year starts off at 0. We'll say while year is less than, let's just do, I don't know, you folks are probably relatively young, right? So if you're 20 now and you retire at age 70, that's 50 years worth, right? The current age to eligible for Medicare, right, is 67, and I'm sure that's only going to go up in the next 50-something years. So let's say 70, right? So sure, we'll do it 50 times. Right, so if you have some amount of money in there, so int will only handle integer values, whole numbers. If I did float, it'll handle numbers with decimal places. So like I could enter, hey, I have $33.57 invested in stocks rather than $33 only. So most people are probably just going to round for us and give us integer values. Yeah, either one's okay. I mean, the math will work either way. Python won't care. Okay, so we're going to take our current value. So let's print it out here. So we'll print, we'll take our current value and we want to multiply it by 1.1. Right, that adds 10%. Again, 10's a little bit generous here, but that's what we're going to go with here. 10%. That was what the S&P average, right? S&P average return. So the S&P is an index of 500 stocks, been a long time ago, so roughly 10 to 11%. Cite source, please. Or maybe there's a citation there that just didn't pull through in this little box here. But, and some years it's higher, some years it's lower, right? And that's how it works, right? But on average, what is this chart here? S&P in grams of gold. I don't even know what that means. Nope. Nope, that's not what we want. All right, that was not an interesting looking chart here. That's fine. No big deal. I was going to look for like a graph of it. I mean, so if you're asking for an input, you wouldn't need to do arithmetic, right? If you're already doing 4 divided by 2 trumpet, then you don't need to ask for anything. You could get their input and then divide by something, sure. Right? So we're going to get their value, and then we're going to do some arithmetic with it. We're going to print, you know what, here, let's do 1 and then less than or equal to 50. We'll say after 1 year, oh, after year, that's the number here, years, your investment is worth, let's put a dollar sign in here to be fancy, right? And then the current stock investment value. And we probably want to format that, right? Probably want to format it here. Oh, if they entered 4 divided by 2, it would crash because it's going to see the slash sign as a character. And 4/2 cannot be turned into numeric values directly. So it's going to fail the conversion to integer because it tries to directly turn the string value into an integer first. So it has to be able to parse it as an integer. So if it sees a slash, it's going to puke. All right, so let's do our format. Let's do an F string because those are easier for us, right? So we can say, hey, I can throw in my curly braces here and say, hey, just throw year right in there. Right, here's our dollar sign. We'll do our current stock investment. Oh, it's getting a little long here, sorry. And then colon, right, 0.2 F for the notation there and the print. I think that ought to round for us. Right? Give that a try. Oh, and yeah, I'm about to do a bad thing. That's okay. It'll be funny. It'll be funny. One math problem, 1, 1. Receipt 1, -1 to stop. 1, no more. Okay. All right, what's the current value? Let's do 100. Ooh, infinite. We're in an infinite loop. We went way too high, way too fast. Right, we crashed it because year is never not less than 50. I forgot to increase year. So I have to make sure I'm going to do year plus equals 1. Right, make sure that this value here you're checking is going to change, otherwise you run into an infinite loop. And that happens, right? That, you know, it's okay, no big deal. Let's try it again. All right, so 1, 1, 1, 1, 1. Oh, -1, 1, no more. All right, so let's do $100. So at 10% every year, right? The first year we gain 10%. The next year we gain 10% of the last year's value, right? So you're seeing the 10% is compounding every time. So after 10 years, we've more than doubled our money, right? After 12 years, we've tripled. After 15 years, we've quadrupled. After 17 years, we've quintupled, right? Is that the right? Sextupled, septupled, octupled, non-tupled. I don't even know what 10 is. I don't know beyond that, right? After 25 years, we have 10 times the original investment here, and we're still going. So if you put $1,000, again, this is a gross oversimplification. It doesn't exactly work like this, but essentially invested it in the S&P 500 stocks or a mutual fund that, you know, is targeting the S&P 500 or whatever here. After 50 years, it'd be worth about 11,000 or so. Right? We do the rounding here. We can even add a comma. I think comma 0.2f, comma 2f. I think that's the format. I always have to go look these up. I don't remember for sure. 1, 1, 1, -1, 1, no. All right, 100. Nope. Okay. Is it comma 0.2f? Let me try that. One of these ways will do it for us. 1, 1, 1, 1, -1, 1, no. All right, 100. There we go. So it gives us the digit separator, which is nice if we have that little comma, which is fantastic. So 50 years, right? It's not too shabby. And that's not even adding more money to the pot. Right? So you see we can use loops to do the arithmetic, and we can actually get our output every time. Now we should get the same number, right? If we took, let me save this here. So the original current stock value is the current stock value. And then for fun, we're going to print out that's the math, right? It's going to be that times 1.1 to the power of 50, right? It should get the same number out. Let's try it. 1, 1, negative 1, 1, no, 100. There we go. Yep, looks like we get the same number out. Right, the math works the same, right? Which is nice. But you don't get all the in-between values. You don't get to see how fast it grows, which is kind of the exciting part. To show somebody, hey, they can turn $100 into $11,000. Right? Sure. Is that fun? And then the other piece, it's harder to add more to the pot. Right? It'd be nice if you can say, okay, hey, do you want to start adding more money? Right? Maybe you only had $100 this year. Can you add another 100 the next year? Or add another 100 the year after that? Or add another 100 the year after that? Right? Let's look at that for fun. Right? So we'll add the 10% interest, and then let's add the current stock investment value plus equals, well, let's add another $100. We'll say add $100 per year here, each year for the 50 years, and see how much we have left. We don't need just the math, right? We can get rid of that one. Okay, we'll give that a run. 1, 1, 1, 1, negative 1, 1, no more. Right, for $100. Right, so the first year we're at 210. And then 331, 461, 610, right? It's going up and up and up and up and up. We're at 128,000 here. Right, okay, let me leave just the math here. Just the original 100. So we can compare. All right, 1, 1, 1, 1, negative 1, 1, no, 100. There we go. Right? So if we add just another $100 per year, right, times 50 years, that's $5,000 we put in, right? For 50 years, we put in 5,000, we end up with 128,000 back. If we weren't adding anymore, we'd have only 11,000. That's not too shabby, right? So this idea of compound interest is phenomenal. And it really works well if your number is large, right? If you're compounding large. If you're only getting 1%, it's not going to do a whole lot. Higher, the more return, the more it's going to compound, especially over those 50 years. That part making sense? I love these examples, by the way. They're so fun. All right, so this is always less than. What if we want to do something silly like how about, we'll say, oh, we did the while you've entered yes to keep on going. Sure. Let's build a random number guessing game here. So let's we'll print, or we'll get a number to guess. To guess is, how about randint from, let's do 1 to 100. And then we're going to ask them to guess a number. So we'll say print, the guess is an int of an input. Guess a number 1 to 100. And while the guess does not equal the number to guess, let's check it. Right? So if they're not equal, if the number to guess is less than the guess, let's do if the guess is less than the number to guess, we're going to print too low. Now, if it wasn't less than, and I know it's not equal, right? Because I can't be inside the loop if they are equal. If it's not less than, it's got to be too high. Then make sure we let them guess again. Right? And we'll just keep on going. Keep on going, keep on going, keep on going. We can play our little game here. 1, 1, 1, 1, negative 1, 1, no, 100. All right, guess a number 1 to 100. So it's a random number we have to guess. I don't know what it is. Right, what should we guess? We'll let chat see if we can win this game here. See, folks have to help me guess. Oh, give me 1 second here while you guys guess. All right, 18, you got it. I'll guess an 18. Right, 18 was too low. Let's guess again, Trumpet Man. 19. That's still too low. All right, so the numbers between 19 and 100. We know that now. They're between 20 and 100, I guess, right? 20? Oh my goodness, 20. All right, still too low. 46. It's too low still. All right, let's keep on going. 57. You got it. Too low still. 65. Still too low. Let's keep going. A little bit of lag in the stream here, I guess. A couple seconds there is a little rough. 75. Hey, we guessed it. It was 75. Look at that. All right, give me 1 second, folks. I got to print this piano lesson for my daughter. Let me flip my screens here. How about we take a 5-minute break? We'll take 5 minutes. We'll come back, say, what does that put us at? 4:23. And I'll be right back. Yeah, you did great there, Trumpet Man. Fantastic. I'll put some music on. I'll be back in like 5 minutes. Sorry. Alrighty, sorry about that. She misplaced her music too. Go print that again. Alright, so we got our loops, right? And we are guessing numbers, right? High to low, and we're just going to keep on going. Now, it would be nice if we had a guess count too, right? So we could have a count of guesses. Starts off at 0, and every time we guess, we're going to check. So actually, it should probably start at 1 here, right? Because that was the first guess. And every time we ask them to guess again, we'll take that plus equal 1. Because it's possible they guess it the very first time, and this loop never runs. So when we're done with the loop, right, we can print out, you guessed it, in count of guesses. Right, and tell them how many guesses it took. Right, so we'll give that a shot real quick. So one math problem, 1, 1, negative 1, 1, no, 100. All right, guess a number. So let's split the difference. We'll start at 50. It's too low, so 75, too low. All right, we got to go halfway again between 75 and 100. Was that 87 or so, I think? All right, 87 is too high, so somewhere between 75 and 87. Let's look at maybe 70 or 82 or so. 82 is too low, so 85 is in the middle. So we guessed it in 5 guesses. Look at that. So now we're counting here. That's part of the fun, right? And we just keep on going. Now, we can also ask them, right? Let's say, how about an int, or a max number is going to be an int of an input. How high of a number do you want to guess to? And then we can do our random number to guess from 1 to the max number. We ask them to guess a number, right? We can do this as a formatted string and throw a max number in here, right? Every time we ask them to guess, so 1 to the max number. And they can keep on going. So they can guess as many times as they want, or guess as large of a number as they want, right? Okay, so 1, 1, 1, 1, negative 1, 1, no, 100. All right, so how high of a number do you want to guess to? Should we guess up to like 1,000? Let's guess a number 1 to 1,000. We'll do 500. Too high. 250. Too high. 125. Too high. Half of 125, was that 68 or so? Too high. All right, so 34. Too low. Okay, so somewhere between 34 and 68. What does that put us at? Maybe about 50? I don't. Sure. Close enough. Too high. So between 34 and 50, let's just do 42. 42 is too low. So between 42 and 50, let's try 46. Too high. 44. Too high. It's got to be 43. We guessed in 10 guesses, a number 1 to 1,000. Right, so I gave this to my kids, and they were entertained for more minutes than I thought they would be, trying to guess random numbers here. And they'd like to pick really, really big ones. A couple of them are old enough to get this split the difference thing. They're not always, their half isn't always the most accurate, but it's close. But my 9-year-old, she would just go 1, 2, 3, 4, 5, 6, and just up and up and up and up. So she was not as interested in it after she did it once, because she's like, that was really boring, Dad. But we can use loops, and we can do these other interesting values here. We can have all sorts of fun. Yeah, so the book has some great examples in loops, which are really fun, that you can go through. All right, so we're about halfway. We've got the next type of loop. I think I want to save for Thursday, and then we can wait on that. So let's do a little more practice with these while loops. We'll have some fun with the while loops. So if you've ever seen ASCII art, it's this idea you can draw pictures using just the text characters. Ours won't be quite as interesting, but we can draw squares here. Yeah, 4 loops, that's right. 5.5 in the Zybook there, Trumpet Man. So let's ask them. We'll have a size, or a square size. Will be an int of an input. I'll enter the size square to print. Okay, and we'll get that value out. Oh, sorry. Don't need to take that call right now. So our square size will be that value. And now we're going to do something. So we're going to say row equals 1 and column equals 1. So I'm going to say while row is less than or equal to the square size, I want to do something. Right? Well, actually, I need column 1 over here. I'm going to set column to 1. So for every row, I need to print this many stars. And I'll go to the next row, print this many stars, right? So if we like look at the notepad and do, hey, here's a 4-star square. So 4 rows of 4 stars. So for every row, I need to print 4 stars. So you can actually, this one's really fun here. You can print, this is a fun thing in Python. We can print the star character times the square size. Square size. Square size. So multiplication, you wouldn't think would work, but it's just going to repeat this many times, which is really fun here. So multiplication and strings, just repeat the string X times. Okay, so if you tell me how big, I'm going to, for every row that I need, print that out. And now I need to make sure I'm taking row plus equal 1, so that eventually this thing will stop. Let's give it a shot. All right, so how many math problems do we got? 1, 1, 1, 1, 1. -1, 1, no, 100. I guess a number 1 to 1. The number's got to be 1. We guessed it in one guess. Look how smart we are. All right, what size square do we want to print? Let's do 4. So we get 4 stars, 4 stars, 4 stars, 4 stars. We get a nice, I mean, it doesn't actually look exactly like a square because our fonts are a little bit funky, but it's essentially a square. Okay? Now, how about a rectangle? Can we do a rectangle? So let's repeat this here. Right, a rectangle will have a different length and width. So this will be our rectangle. And really, we should probably talk about height and width instead of length and width, because I think height makes more sense in terms of row here. So this will be rectangle height into the size height of the rectangle to print. And then while our row is less than the rectangle height, we need to do something, but we also need the width. So we need a rectangle width is an int of an input. Enter the width of the rectangle to print. Well, I was doing a rectangle instead of a rectangle. Okay, there we go. And now instead of multiplying by the square size, we're going to multiply by the rectangle width. So for every row in the height, let's print the width. So now we can get a rectangle out. So what size rectangle should we do? Like a 4 by 2 or 100 by 10, or you come up with something there in chat while I go through all these silly prompts. 1, no, 100, 1 to 1, size square, a 10 by 10 square. Okay, great. Now we're at the rectangle. So what height rectangle should we print? A 7 by 5. Okay, so 7 by 5, and we get 7 rows, 1, 2, 3, 4, 5, 6, 7, each with 5 stars. That's a pretty little rectangle, isn't it? We're now doing some ASCII art. Again, you can do other characters, you can do all sorts of fun things like that, and that's how you actually build ASCII art. But you know, for our purposes, we're just going to use a star because it comes out nice. Other characters don't fill quite as well, necessarily. So like a lot of people like the pound sign, too. That one's kind of fun. And yes, I'm old enough, I call it a pound sign instead of hashtag. It was called the pound sign long before it was called a hashtag. So I think, I don't know, I feel like an old person when I complain about that. But that one, you know, turns out for a pretty print as well. Okay, so we can do little shapes here with our loops. Now, here's a fun one. How about a right triangle? Like 1, 2, 3, 4. Could you do a right triangle? Right, it's all about what's the relationship between the row number and the number of stars we have to print. So row number 1, we print 1 star. At row 2, we print 2 stars. At row 3, we print 3 stars. Row 4, we print 4 stars. Sure, we can do that. So I'm going to take the square size one here, and I'm going to repeat. We'll say enter the size right triangle to print. And this will be my triangle size. And as long as row is less than triangle size, we want to print, well, if there's 1 star at row 1, we can print star times the row here. Right, inside of our loop. All right, so 1, 1, 1, 1, -1, oops, -1, there we go. 1, no more, 100, 1, it's number 1 to 1. 20 square, sure, that's big. 20 by 30 rectangle, that's large. And the pound signs. All right. So what size triangle should we do? The technical term for a pound sign is octothorpe. I feel like I've heard that before. But, it probably sounds just as weird to say octothorpe as it does pound sign to people who know it as a hashtag. But I like that. Maybe I should call it an octothorpe. Why 8 though? 8 what? It's octothorpe. All right, we gotta Google this now. Octothorpe. Another term for the pound sign. Oh, because it has 8 outer edges. I gotcha. 8 prongs. Okay. All right, what size triangle should we print? 8 prongs. So thorpe is like a prong? Interesting. Interesting. Octothorpe? Is that how you pronounce it?
Octothorpe.
Octa. Oh, it's not octo. Octothorpe.
Octothorpe.
Octothorpe. Can you hear that?
Octothorpe.
Let me turn on the PC volume here. You gotta hear it.
Octothorpe. 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 Octothorpe.
Alright, anyway. So what size triangle should we print? Like 20? Let's do 20. Look at that, we got the gorgeous looking right triangle here. And that's probably 20 stars there. So if you see down at the bottom, you can't... Oh, you can see it. So just beside my picture here, it tells you, hey, you've highlighted 20 characters. Isn't that cool? So it'll tell you how many characters you've highlighted, which is really fun for quick counting. Okay. All right, I think that's good. So we left off at 5.5 here. And we can pick that up next time. So I'll go commit this code to GitHub. So on Thursday, we'll go over the solution to Project 1. Hopefully you picked up some of the hints that we looked at doing some while loop examples here. And that'll make life easy for you. If you got stuck on anything there, let me know. Oh, not lab 1. Nope. This one here. There we go. All right. Changes. We got... That's 1501. My goodness. There we go. This is the right repository. We got to get there. I see my main py file, all the other PyCharm stuff. Great. We're going to commit it all here. This is while loops. All right, we'll commit and push that. Should be in pretty good shape. Hey, you want to go send a raid off somewhere? You folks want to say hi to someone else in Twitch land? That sound like fun? On the ending screen here. We can go send a raid off somewhere. Let's see who's around. And we should definitely share the knowledge of the octothorpe, being the pound sign or hashtag. Let's see, who is around? Trying to find out who's around so we can send someone. Oh, bother's streaming again. We've rated him before, though. He's really cool, though. He's trying to do... I think he's even writing Python code. We should raid there anyway. Because he's having fun with his new board. He's going to burn subnames on with his laser. Super cool. What a fun project in Python. So we'll head over that way. You take care. I'll see you folks on Thursday.